Hello, guys. Let us look at number 16 and on. We see that isosceles trapezoid. What is so special about isosceles trapezoid? The two sides on the two non-parallel sides are always congruent. Then we can set up an equation in this way. 2x plus 5 must be equal to 3x plus 2. Then subtracting 2x from each side and subtracting 2, then we'll end up getting x equals, in fact, 3. And they want us to find the value of x. Okay, we got it. X equals 3. Number 17. Isosceles trapezoid ABCD. So here, okay, something like this. And then here we have A, B, C, D. And AC now then it becomes diagonal, so is BD. So here AC, and what do you realize about the diagonals in isosceles trapezoid? In fact, they are congruent to each other. So the equation which we can write up is 5x plus 13 must be equal to 11x minus 5. Then we can subtract 5x from both sides and add 5. Then you can see that 18 is equal to 6x. When you divide each side by 6, x will be equal to 3. So therefore, our answer will be choice 3. All right, let us look at number 18. We have triangle ABC, and then triangle D. Let me just use a different highlighter. DCB. They are congruent. Now that makes these two sides to be congruent, making this one as an isosceles trapezoid. Now, then the question is AC congruent to BC? Oh, we have no idea about that one. Is CD congruent to AD? CD is congruent to AD? Not necessarily. Is the angle CDE? CDE, which means this angle, right over here, is that congruent to BAD, which means the entire one? Oh, not quite. Is CDB? Once again, that will be this angle. Is that congruent to BAC? Yes, that's what it seems to be. By CP, CTC. All right. Now, let us try to look through this one together. All right, so I'm going to assume that A is negative 2, 2. That will be equal to A. And 6, 5 is B. This will be 6. That's B. And then C is 4, 0. And then the last one is negative 4, negative 3. They will be D. So it looks like some sort of a parallelogram. Now, how can you show that if something is a parallelogram or not? To show that it's parallelogram, then we can say either opposite sides are congruent, or opposite sides are parallel. Now, to show that opposite sides are congruent, we'll be using distance formula. Opposite sides are parallel, then we'll be using the slope formula. Alright, but the second portion, not a rectangle. How can you show that if something is a rectangle? We need to show that there's sides are perpendicular to each other, which once again using the slope formula. So since both of them requires some sort of slope formula, why don't I use the slope formula to figure out the slope for all four sides? So here, slope for AB is y2 minus y1, so 5 minus 2 over 6 minus negative 2. And you can see that that must be equal to 3 over 8. Now we're going to go for slope for BC. Slope for BC would have been 0 minus 5 and 4 minus 6, which will be equal to negative 5 over negative 2, which is the same thing as simply 5 over 2, because 2 negative makes a positive. Now, next line segment is slope between 2 points C, D. So first one will be 0 minus negative 3, negative 3 minus 0. Then in that order, we're going to have negative 4 minus 4, which will be equal to negative 3 over negative 8. But once again, 2 negatives makes things into positive, so we get 3 over 3 over 8. Then you can see that these two has the same slope already. Great. So let's go for the last line segment, which is slope of AD. So first it will be negative 3 minus 2. Negative 4 minus negative 2. Then what do we get on top? We get negative 5. On the bottom we get in fact negative 2, which is equal to 5 over 2. So therefore we realize that opposite sides has same slope. So one of the statements which we can write it would have been something like this. Since opposite sides have the same slope, opposite sides are parallel. This shows that ABCD is a parallelogram. Alright, but how about the second portion? We still didn't do, but not a rectangle. We can say that here since slopes of consecutive sides are not perpendicular or not negative reciprocals, ABCD is not square. Alright, so that was number 19. Let's move on to number 20. In this case, all we have to do is simply prove that the quadrilateral is a rhombus. Same way as before, we're going to first draw the line segment here. -1 comma -5, that's A. And B becomes A comma 2. And then C would have been 11 comma 13. So it goes up till 11, and then here 2, 4, 6, 8, 10. So it's going to be somewhere around here. And there will be C, and D is 2 comma 6. And then we want to connect them. Alright, so here we have, it looks like a rhombus, but in order for us to see that it's a rhombus, what are we going to do? We're going to get the distance for all four sides. So first, AB. AB is x2 minus x1, so 8 minus -1. Square. That's the x2 minus x1. And then the next one is y2 minus y1, so we have 2 minus -5. Square then. Here we get 9 square becomes square root of 81. And then here we end up getting 7 squared, which is 49, which now is equal to square root of 130. Now, that was AB. Now let's try to figure out BC. BC is, so first 11 minus 8. And then 13 minus 2. Here then we get 3, so we get 9 plus this one is 121, which is equal to still 130 as our answer. That's for BC. How about CD? So CD is change of x becomes 2 minus 11 . 2 minus 11 square, okay. Now, CD, so 6 minus 13 square, then what is that? Then it becomes 9, and it becomes 12, negative, actually, 9 square. And then this one becomes 7 square. So we get square root of 130 once again. And let's go for DA. So DA becomes 2 minus -1. Square plus, and the next one is 6 minus -5. Square. So then here we get 2 minus -1 becomes 3, which ends up being 9. plus here 6 minus negative 5 becomes 11, so we get 11 squared. Oops. 11 squared is 121, so when you combine them together, we get square root of 130. And that becomes our answer for number 20. Let's go for number 21. We need to show that this is trapezoid. So what I'm going to do is this. I'm gonna first sketch this one. And a is equal to 1 comma 6. And then second one is 7 comma 9. Okay, that's B, and then C becomes 13 comma 6. Comma C, and then D would have been 3 comma 1. And then let me try to connect them together. Alright, so this is the picture of the something that which we like to prove. So then one school of thought, the only thing that which we need to do is at least one pair of sides are parallel. But another group of people, which will be more, which in fact is more popular, is we need to show that one pair is parallel, the other side is not. So then first let's try to figure out the slope of AB. What is the slope of AB? Then that's equal to change of y, which is 9 minus 6 over 7 minus 1. What is that equal to? We get 3 over 6, which is equal to 1/2. Now let's try to find the slope of CD. CD becomes change of y is 6 minus 1 over 13 minus 3, which will be equal to 5 over 10, equal to 1/2. Great. So this one shows that ABCD is trapezoid. So my statement will be, since AB is parallel to CD, ABCD is a trapezoid. Now, the second portion is that I guess that's it. Some other people's cases, what they'll be doing is AD is not parallel to BC, but that's up to you. Alright, let's look at the last question here. We all know that it's a trapezoid, but not an isosceles trapezoid. Showing that something is a trapezoid, we can do something similar to what we have done just now. Alright, now plotting the points T, R, E, P. So T is negative 1 comma 1, and then 3 comma 4, A is 7 comma 2, and D is negative 1 comma negative 4. Alright, so from here or actually last point was -1 comma -4. So here, all right. To show that it's a trapezoid, we want to show that a TR and then AP. This is A, this is P. So to do that, we're going to have slope of a TR so 4 minus 1 over 3 minus -1, which is equal to 3 over 4. Now, slope for AP so we get slope for AP. So on the numerator, we will end up getting changes of y. So we get 2 minus -4 over x was 7 minus -1. Then we get 6 over 8, which is equal to 3/4. And you can see that since both of them has the same slope, we know that the TRAP is a trapezoid. Since there is one pair of size TRAP is a trapezoid. Alright, now but we also need to show that it's not isosceles trapezoid. The word isosceles here means equal size. That means let's try to figure out TP. TP would have been the last one, so we get -1 minus 1 and then square, and then y would have been -4 minus 1. Then you will realize that this comes down to 5 because first term becomes 0. How about AR? Distance between AR would have been change of x, so 7 minus 3 and then 2 minus 4. Then here we get square root of 20. You see, two sides are not equal to each other, since non-parallel sides are not congruent. TRAP is a trapezoid. Trapezoids is not an isosceles trapezoid. Alright, that's it. So we're going to stop now, and I'll see you later. Bye-bye.